Alright, we are back. This is Techmath2. We're looking at the review for chapter 7 and 8. So let's jump into it. We've got solve for r. So there's a square root, but it's an equation. So what we can do is square both sides. And because you're squaring the entire square root, that wipes out the entire square root. So we have just 2r minus 5 over 4, and that equals 4. And now it's just cross multiply and solve. So 2r minus 5 equals 16, and then isolate the variable. That's add 5 to both sides. That gets the r all by itself, and then divide by 2. And so 10.5 or 21 halves. Or 10 and a half. Any of those three are fine. Let me get a different black marker. Just like in real class. The marker is dying. Okay, so this one, first we have to isolate the square root. So they have this 5 out in front. We're going to divide both sides by 5. And that'll cancel there. And so we have the square root of 2s over 3s minus 5. I wish they wouldn't use s. I wish they'd just stick with x. Okay, so 10 divided by 5 is 2. Now we're going to square both sides, just like what we did up top. And so you got the square root and squared cancel each other off. So that's just 2s over 3s minus 5. Equals 4 over 1. Cross multiply and solve. So you have 4 times 3s minus 5 equals 2s. Do the distributive properties. So you have 12s minus 20 equals 2s. Subtract 12s from both sides. That'll get all of the s's over on this side. So we have negative 20 equals negative 10s, and then divide both sides by negative 10. So 2 is equal to s, or s is equal to 2, either way. All right. Next one, we have to cross multiply to start. So we have 5 square roots of 3x equals 4. Then you want to isolate the square root, so you divide both sides by 5. And now the square root is all by itself. And now square both sides. And so you have the square root of 3x squared, so the square root and the squared cancel each other off. You just have 3x. That's equal to 16 25ths. And again, you got to see if they want a decimal or if they want a fraction. It looks like they want a fraction for this one. So instead of dividing by 3, when you have 3x equals to a fraction, multiply by the reciprocal. So instead of dividing both sides by 3, we multiply by 1/3. You're doing the same thing, by the way. If you divide by 3, you're doing the same thing. It's just easier to look at if you think of it as multiplied by 1/3, because then x is equal to 16 75ths. All right. Okay, so square both sides. This, the y minus 1, just as y minus 1. This, you have to go back and do either the distributive property twice or FOIL for summary last, however you learned it. So y squared minus 3y, and then the minus 3 goes twice, so minus 3y plus 9. So you got y minus 1 is equal to y squared minus 6y plus 9. Then we gotta get all this stuff over to that side, so minus 1y and plus 1. So now you have this. Y squared minus 7y plus 10 equals 0. Now, in 115, we learned a couple of ways to attack a second degree problem like that. You could just use quadratic formula and do a, b, and c, and do the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's not the easiest way to do this one. This one is factorable. And so I'm going to do it by factoring. That is, you figure out what multiplies to be this last term, but adds up to be that middle term. So you build a list of suspects on that last term. Things that multiply to be 10, but add to be a negative. So it's got to be negative, negative. So negative 1, negative 10. That adds up to negative 11. So that's not what did it. Negative 2, negative 5. That multiplies to be positive 10 and adds to be negative 7. That's what it factors into. Okay, so we have that. Now you go back to grade school when you learned how to multiply. And anytime you multiply by 0, you get 0. But that works both ways. So if you got to 0 through multiplication, the only way that can happen is if there's a 0 in there. So you set that equal to 0, that equal to 0, and solve. We get y equals 2, and we get y equals 5. Now, every time that you square or take to the 4th power or take to the 6th power, anytime you do even powers on both sides of an equal sign, you must check your solutions because you will get what's called an extraneous solution sometimes. Sometimes not. Sometimes both of them work. Sometimes none of them work. Sometimes, or one is extraneous and one isn't. So let's take a look. If I pop in 2, I have 2 minus 1. That is, let's see if this gets us a true statement. The square root of 1 is equal to negative 1. 1 does not equal negative 1, so that's wrong. That's an extraneous solution. Let's try the 5. The square root of 4, does that equal 2? Yes. So this one works. So because we squared both sides, basically we created an answer that it was going to be the opposite of. Because 2 minus 3 is negative 1. It's not positive 1. So that's usually when you find an extraneous solution, you're finding it because when you put it back in, it doesn't work, but it usually involves a sign, like a negative sign. All right, so we're going to keep going here. That was number 4. That was a lot of work. Okay. So, number 5. These are really the same problems. It's just they're giving you an equation and then they're giving you pieces of the equation. So they tell you V is 13,200, R is 3,960, and go ahead and find H. So we say, okay, 13,200 for V. I'm going to write that out. 1, 1, 1, 2, 3, 4 zeros because it's times 10 to the 6. So that's 6 places to the right. So it's actually 1,110,000 is what's going on there over the square root of R. They told us was 3960 plus H. And so after you sub in the values, I mean, these are bigger numbers, but we're using calculators anyway, you do it the same way. So we're going to cross multiply and solve 13,200 square roots of 3960 plus H is equal to 1.11 million. All right. Isolate the root, isolate the square root. So we'll divide both sides by 13.2. And so that doesn't end up pretty. That's 84.09090909 forever. Okay. Square both sides. That gets rid of the square root sign. So we got 3960 plus H is equal to 84.090909 forever is 70, 71.280992. Then subtract the 3960 off. And H is equal to 3,111.280992 miles. But wait, you have to read carefully. They said round to hundreds. So hundreds place is right here. That's 3,100 miles. That's always tricky when they say hundreds because you're used to hundredths, you know. So if you put down 3111.28, you made a common error. All right, so make sure to read it carefully what they want you to round to. So that was 5. Let's take a look at 6. Solve for a, so t is equal to the square root m squared minus 2a for a. So this time they do not give us values to put in. So now we're kind of shifting from a different kind of problem solving now. We don't have numbers to work with. We've got all these variables. So they basically are saying treat a like it's the only variable and treat everything else like it's a number. So the first thing we would do is square both sides to get that out of the square root. So t squared is equal to m squared minus 2a. Then we would move the m squared over. T squared minus m squared is equal to negative 2a. And now we would divide both sides by negative 2. So the whole thing divided by negative 2. Now, I'm okay with you leaving it like this. If you told me t squared minus m squared all over negative 2, I'm fine with that. If you look at the answer and you look what I did not leave it like that. A lot of people consider it bad form to leave a negative number that's dividing into multiple things like that. And so what you could do is multiply the top and the bottom by negative 1, and that'll take care of the 2, so it's now positive. And then you have negative t squared plus m squared, and so they usually, the book will always write it the other way, m squared minus t squared, so they don't have to write it, the negative out in front of it. I don't care, again, if you wrote negative t squared plus m squared, that's fine, or m squared minus t squared, that's fine. Either way, over positive 2. All right, let's take a look at number 7. Okay, number 7 is t is equal to 2 pi square roots of p over d for p they want me to solve. So, just like before, we want to isolate the root. So we'll divide both sides by 2p. So t over 2p is equal to the square root of p over d. But then we don't want a square root around it, so we're going to square both sides. Be careful with that because the pi gets overlooked a lot of the time. So t over 2 pi times t over 2 pi is t squared over 4 pi squared. That gets left off lots of times over my career. And then p over d, and so now you could cross multiply and solve, but it's easier if you just say, okay, well I want just p, so if I just multiply this side by d over 1 and this side by d over 1, I get p is equal to dt squared over 4 pi squared. Just like that. All right. Let's take a look at number 8 is a lot easier, I think. you've got m is equal to c times the square root of a over b. And so they want you to solve for c. So you say, okay, just multiply by the reciprocal. But to multiply by this reciprocal, we'd have the square root of b over a times the square root of b over a. And that would be it. It would be m square roots of b over a is equal to c. Because that would cancel away, it'd just be 1. All right. I also had it, some of you may have had an algebra teacher that made you rationalize the denominator. So you could have this also where you have the square root of ab over a. And what you did there is you multiplied top and bottom. Here's the process of that. Multiply top and bottom by the square root of a to make it so on the bottom, on the top, you have ab, square root of ab. On the bottom, you have the square root of a squared, and then that's just a. You do not have to do that for this course unless they specifically tell you to rationalize the denominator. So that is not required. You just leave it like this. This is fine. That's fine. All right. Lovely doubly. Let's take a look at number 9. Solve for b. You got a is equal to the square root of b over 1 minus b. So you're going to square both sides. Minus b. Then cross multiply. Right? So b times 1 is b. A squared times 1 minus b is squared minus a squared b equals b. Add a squared b. Add a squared b. A squared is equal to b plus a squared b. Now, the reason I moved this over to this side is we're solving for b on this one. So that means I'm going to have to factor out a b. And then get 1 plus a squared, and then divide by 1 plus a squared. And that is your answer. A squared over 1 plus a squared is equal to b. Do not do anything silly like canceling a squareds. They're being added on the bottom. You cannot cancel things that are being added or subtracted ever. All right. Do. Two more problems, and then stop the presses. Ten is d equals r over 1 minus m squared. They want me to solve for m. So I cross multiply. Oops, wait, I left off a square root. I cross multiply. I got d square roots of 1 minus m squared equals r. I divide by d. I've got the square root of 1 minus m squared equals r over d. I wanted to isolate this square root. Now I square both sides. So I have 1 minus m squared is equal to r squared d squared. I add m squared to both, or no, not add m squared, sorry. Minus 1 from both sides, so I have negative 1 m squared equals r squared d over d squared minus 1. And now I divide everything by negative 1. So I end up with this m squared is equal to negative r squared over d squared plus 1. And then I take the square root of both sides. But m is equal to the square root of, and I'll write it the other way around, 1 minus r squared over d squared. And so that is a good answer. You just leave it like that. That's fine. They may have had a different version of it. I'll show you what they were thinking. You don't have to, but you could make it into squared minus r squared over d squared like this. Say that's d squared over d squared, so you have a common denominator. Then you could say d squared minus r squared over d squared, all square root. And again, you can't do anything with the square root of the d squared minus r squared. But on the bottom, you could escape that d. That's fine. I'm okay with this. I'm okay with you leaving it as a fraction with a square root on it. Again, this would be, you would go through these steps to rationalize the denominator, but it's okay if you leave it like that. All right? And here, we'll do number 11, and then we'll stop this tape and do a part 2. So this is part 1. Okay, so number 11 is 2kt equals 1 over 2mt, and they want you to solve for t. So there are t in 2 places, but you can remedy that by cross multiplying 4kmt squared equals 1. And then just divide both sides by 4km. And then you have t squared equals 1 over 4km. And then take the square root of both sides. Again, officially, algebraically, it should be plus or minus. It's just in this book, in this course, we're usually entrenched in the real world, and there's a domain restriction saying it has to be a positive. We don't want negative answers, so we usually are just kind of circumventing that and saying, yeah, don't worry about that. All right, so now you really should take the square root of 1 and the square root of 4, square root of km. So the 1 I'll give you either way because the book has the square root with the 1 on the top, not in the square root. But you definitely have to do the square root of 4. It's being multiplied, so you can separate them into perfects and leftovers. And then just a regular 1 on top. If you look, the book has it with the square root of 1 over km. Yeah, that is a little bit of bad form that they shouldn't have it like that. But this is fine, like this. Again, you could rationalize the denominator if you wanted to, and then you'd have the square root of km over 2km. All right? Lovely, lovely.